Recording. So, like I said, today we're going to be looking at exponent rules. So there's 4 rules we'll be looking at today. I believe, right? Yeah, it should be 4 if I remember right. When multiplying powers with the same base, you simplify the exponents by adding them together. And just a little bit about vocabulary. Like, say you have x up to the power n, like your number that's being raised to the power, that's called your base. And this is obviously called, like the n would be like your exponent or your power, or there's other synonyms you could use. So for example, if you have the same base, so like in this first example, you have a 4 and a 4, you add the powers. That would be, so you would add the 5 and the 3, because that would be 4 to the 8th. The reason is, like, I mean, you don't have to write it out this way. You probably don't want to, but remember, 4 to the 5th is really 5 4s, and 4 to the 3rd is really 3 4s. Sorry if I could say that right. But if you count how many 4s you have, you should see you have 8. So, I mean, that's the reason it is this. I mean, you don't have to write it out like what I did here, but that's the reason why. Oh, let's try it. So same idea if you have more than one. I mean, as long as your base is the same, like these are all 2 up to a power, you're just going to add those exponents. So 4 plus 6 plus 2, 4 plus 6 is 10, plus 2 would be 12. So this would be 2 to the 12th power. I mean, if you really want to, though, I mean, like if you wrote that out, that's 4 2s, that's 6 2s, and that's 2 2s. Like, I mean, usually you don't want to write it out, but like that's why this rule works. Like if you expand those powers, that's why you can really add them together. Same idea if you have negatives, like as long as you have the same base, like these are both 3 up to the same power, like you would just add 6 plus -2, that would be 3 to the 4th. So, I mean, negatives don't really change it when we're using this property. So same idea here, you would add the powers. 2 plus -8 is -6. Plus 6 would be 0. This, I'm not sure if you guys know, like if you remember this, but anytime you have a number up to the 0, it's 1. Like you could put that in your calculator, like any number, like put 9 up to the 0 power, it's going to give you 1. So just one kind of side rule, if you have a number up to the power of 0, it's always equal to 1. I don't know. I don't think we're going to define that later if I remember right on these notes, but that's something to keep in mind. But if you put it in your calculator, you should see that that is equal to 1 for any number up to 0. And give me 1 sec. All right. So sorry. So the rule for multiplying powers with the same base, there's different ways you could write this, but if you had x up to an a power times, let me try and rewrite that. Sorry, x up to an a power times x up to a b power, well, that would be the same base, and you would add the powers or the exponents. And I know my a, that looks like a 9. That's a lowercase a there. Okay, so your base, when you're multiplying, your base doesn't change, just you add the powers together. And so we're going to look at some expressions, but when you're simplifying algebraic expressions, you combine like terms and then you simplify. So let's look at this one. So example 1 here, like if you have like something like a number, like a variable up to a power times a variable to a power, you multiply the coefficients. So like 4 times 9 is 36, but the powers you add, because that's really 5 z's times 2 z's, so you have 7 z's in total. So you multiply the coefficients, but you add the exponents from what we saw above. So kind of try and keep that straight. I know because you're switching operations, sometimes it's easy to mess that up. But same idea for problem 2. You would multiply your coefficients, So 2 times 9 times 3. So 2 times 9 is 18 times 3, that would be 36, 54. And then just be careful in a problem like 2. Like you can only do the a's together. So a and a squared. Remember, this is really a up to the first, or you really have one a. So one a and two a's would be three a's. And then your b, I mean, it's the only part like that, so it just stays the same. So keep in mind, they have to have the same base. Don't just be adding all the powers no matter what. Make sure they have the same number or variable up to that power. So like you can't combine the b to the fourth with the other a's. Because I mean, if it helps you visualize, like you have one A, you have four B's, and you have two A's. So like really together we have three A's and we have four B's. So that's the multiplying powers with the same base, or the multiplication property of exponents. So hopefully this is a little bit familiar. It's probably been a while since you done it though. Our second rule is raising a power to a power. So the general rule to raise a power to a power is going to be, you're going to multiply these. So like if you have something like this, a to a power up to another power, that would really be a up to the m times n power. So for example, 5 up to the fourth up to the second would really be 5 up to the eighth, because you would basically multiply the 4 and the 2. Or another way to think about this is you really have 5 to the fourth times 5 to the fourth. So like really you have 8 5s. And you could put this in your calculator and get a number. But I'm pretty sure in Delta Math, they're going to have you keep it in this form. But I mean, if you wanted to put this in your calculator, 5 up to the eighth, like you could expand what this actually equals. So let me put that in my calculator. 5 up to the eighth power is, I mean, it's 390,625. You're going to see these get really big fast a lot of times when you're taking powers. But a lot of times you just leave your answer like this. I mean, but sometimes if you want to expand it, you can write it like that. So it kind of depends. In Delta Math, like I said, I think most of the sections, I know one of them, you're going to keep your answer like in this form. You're not actually going to put it in your calculator all the way. No difference if you have fractions. Like, I mean, we have x up to the 1/2 up to the 2/3. You would just multiply these fractions together. And I know a lot of you guys don't have a red calculator. One tip when you multiply fractions, you multiply the top. So like the 1 times 2 would be 2. And you multiply the bottom, 2 times 3 would be 6. And if you want, you could simplify that, like 2 over 6 would reduce to 1 over 3. But if you have a calculator, like one of those red calculators, I mean, you would just do 1 ABC2 times 2 ABC3. Like it would handle it just fine. Same idea with variables here. I mean, like you have p to the 6th up to p to the 3rd. So that would just be p to the 18th. So just kind of using those exponent rules. So that's a power to a power rule. So basically, if you have something up to a power, you multiply the exponents. But let's look at, oh, I forgot, it's separate pages. So let me open up the second page of the notes. But we're going to look at a little bit more complicated. But so kind of building on that rule we just saw, raising a product to a power, you raise each part or each piece to the power and multiply. Maybe a more technical term, usually we call it a term in math, but basically each piece or part of the thing we raise the power. So say, for example, you had a constant. Like you got to take it to the number in front as well. So this would be like a squared x to the 2n. I know that looks a little bit strange, but let me just show you it like in an example. So if you have more, like you have a 3 and an x on the inside, and keep in mind this is really 3 up to the first power, x up to the first power. We usually don't put the first power. You got to multiply both of these exponents by 4. So this would be 3 to the 4th, x to the 4th. Same idea here. This is 4 up to the first, b up to the first. So when you raise this power, this would be 4 squared b squared. And you can simplify these more. It kind of depends what you're doing, but I mean, Like for example, in example 1, 3 up to the 4th power would be 81. And if you put 4 squared in your calculator, that's 16. So sometimes like it depends like how they want you to leave your answer, if they want you to expand it or not. And how you put this in your calculator, if you're not sure, there should be, most calculators, they have like a caret button. It looks like this. And then you just put the number you want to raise it to. So there's no like specific 4th power button on your calculator, but you should see that, like, we call it the caret key, that like kind of arrow or part of a triangle pointing up. So I just wanted to look at just a few examples, just so you have these, or if you want to look at these as you're kind of going through the delta math, either if you want to start it today or if you're looking at it tomorrow. But you just want to pay attention to what's happened. Like this would be the multiplication rule. So you add those powers together. That's really x to the 5th. Because like I said, that's really 2 x's times 3 x's. So I mean, altogether you have 5 x's. 3 squared up to the 4th power, power to a power, you multiply. So that would be 3 to the 8th. And it depends in delta math. Like sometimes they might want you to keep you in power form, but if you want to put that in your calculator, like 3 caret button 8, that would be 6,561. And you're going to see for a lot of these exponent problems, you're going to get big numbers quick for a lot of these questions. Keep in mind number 2, it looks different than number 6. Like I know you see parentheses, but this is multiplication. It's not like a power to a power. So we're going to multiply our numbers in front. So 3 times 7 is 21. And then you're going to add your exponent. So you have 2 a's and you have 5 a's. So that would be 7 in total. This one is a power to a power, so you would just multiply. So it'd be a to the 14th. This is another multiplication one. So multiply the numbers or the coefficients. So 2 and -5 would be -10. And add your powers. Like I said, if you don't have a power, it's really up to the 1st power. So that would really be 4 y's. Same idea with this one. I'm just gonna kind of work, I know I'm working these out quick, but I just want you to have these examples to reference. Remember, this is 5 to the 1st, y to the 1st, so that would be 5 to the 3rd, y to the 3rd. You got to take both pieces on the inside up to that power on the outside. So that would be, if you put that in your calculator, that's 125 for 5 to the 3rd power. Same idea here. Your coefficient would still be a 4. Then look at your x's. So you have 1x and 1x. So that's 2 x's. And then your y's, you have 3 and you have 2. So that would be 5. Oh, cool. And then there's Quante coming in. Same idea here. I mean, you got to take both parts up to that 2nd power. So that would be, oops, that would be 3 squared z squared. Well, that would be 9z squared. When you put 3 squared in your calculator, that's where I'm getting the 9. So on and so on. I mean, like I said, I mean, I don't know if you guys have questions, but this should be review. But I mean, if you multiply your coefficients, that would be -6 times 2. That's -12. Look at your a's separately. So you have 2, you have 1, you have 3. So I mean, altogether, that would be 6 a's. Then look at your b's. You have 1, you have 3, you have 2. So that would also be 6 if you add those all up. Let me rewrite that, it's sloppy. And same idea here. If you have like a power, you have to take that each term up to the 3rd power. So I mean, that would be 6 to the 3rd, a to the 6th, and then you could take 6 to the 3rd in your calculator. That would be, it's 216. Let me plug that in. Yeah, it is 216.